Hello, my name is Leo. Today we're going to talk about measuring units for computer data. The basic unit of digital information is byte. One byte has 8 bits, and one bit can have one of two values, 0 or 1. As in the past there were always smaller amounts of data, such as kilobytes, megabytes and gigabytes, the problems with real data amount weren't so emphasized. But when mathematicians and physicists said they didn't agree with the fact that, for example, 1 kilo is 1024 because kilo as a prefix means 1000. Today we speak about much bigger amounts of data, such as terabytes, petabytes, so there have appeared even greater noticeable differences between data amount in theory and in practice. We have these two worlds of data amount, math world, which is world of theory, and computer science world, which is world of practice. So how does computer really represent computer data? In math world is decimal base, number 10, where 1 kilo is 10 on the third power, so 1000, and 1 mega is 10 on the sixth power, 1 million, or 1000 kilos, and so on. In computer science world is binary base, number 2, where 1 kilo is 2 on the 10th power, 1024, and 1 mega is 2 on the 20th power, or 1024 kilos. Now let's compare these two worlds by calculating difference between two equivalent measuring units in these two worlds. In this example we have gigabyte in computer science and in math world, and here is their difference. Their difference is about 6.87% of 1 gigabyte in computer science. And this relation of how big part is this difference of the bigger measuring unit, which is always this one in computer science, is represented in these two graphs below. We can see it is exponential dependence. So the bigger measuring units are, also is bigger their difference. Before, data amount, so amount of computer data, was expressed in SI standard, which is International System of Units, which has a decimal base, so base of number 10. And in 1998 was suggested new standard, IEC standard, or International Electrotechnical Commission, which has binary base, so base of number 2, and finally came into practice officially in 2009. Here you can see an example of old hard disk drives which had always smaller amount of data than it was written on their labels, because their memory location was expressed in this old SI system. And here is an example of this measuring unit from the SI system, 1 terabyte, which is about 91% of 1 TB, which is equivalent measuring unit in the new IEC system. And here we have a loss of about 90 gigabytes. Since about 2 years, producers of data storage have begun to express by new standard. And although the new standard is officially in use, computer components are still expressed by the old standards, so in kilo, mega, giga, terabytes and so on. Because of the mentioned cause, people from computer science, especially those ones who are designing computer systems and who are choosing computer components, have to pay their attention to this new standard, so as to express themselves by a new standard when calculating computer data, amount of computer data. And here you can see also these measuring units from the new IEC system, which are Kibi bytes, Mebi bytes, Gibi bytes, Tebi bytes, Mebi bytes, and so on. Hope we'll see soon Kibi, Mebi, and Gibi in operation systems and softwares. Now you've learned the difference between kilo, mega, giga and Kibi, Mebi, Gibi. Thanks for watching and stay with us.